Thank you for coming. So my talk has a weird name, as you've seen, because it is in fact 2 talks for the price of 1. So you're going to get 2 slightly different talks today. The first one is going to be on my day job, which is I'm a team lead for a large enterprise project written entirely in Kotlin. And the second part is about a side project which turns Java and Kotlin JVM apps into small sort of standalone native binaries like what Go would produce. So it's actually very different content. I figured I'll throw in a bit of both, and that way the people who don't care about enterprise software will have something, and the other people same. But we're going to start with R3 and Corda. Right, so this is the startup that I work for. Okay, firstly R3. R3 is both a startup and a large consortium of banks. Now, I didn't think such a thing could exist until I saw it with my own eyes. It seems like a bit of a contradiction in terms, but it is possible. And R3 started out as a bunch of finance guys who wanted to help big institutions navigate all of the hype and excitement and interest around blockchain technology, which of course came out of Bitcoin and so on. And they created this sort of consortium, and you could pay some money and become a member and get access to working groups and research papers and so on and so forth. And one of those working groups was exploring the technology and intending to make recommendations to developers of blockchain technology on what it should look like for banks and other big organizations to adopt it. And pretty quickly we realized no one was going to listen because they were all pretty much off doing their own thing, and they didn't really care about what the industry needed. They didn't really care about what banks needed in particular. So we started a project, or effectively we started prototyping some of these ideas we had. Those prototypes developed, and they became Corda, which is an open source blockchain or blockchain-inspired platform developed by this large consortium of banks. So that's what the first part of this talk is about. So I'll just briefly introduce myself. So I am most importantly for this conference, I'm a Kotlin early adopter. I went back and when I was writing this talk, I looked at my commit history and so on, and actually my first contribution to Kotlin was attached to the website in September 2014. So I'd been using it or playing with it a little bit before that. At the time, I was, well, just at the end of 2014, actually, I was working for Google, but I left January 2015. I created my own product, and I started using Kotlin in that as well. No, sorry, I was actually self-employed at that time, and I created this product, and I introduced it to my first product there when I was self-employed. I am the lead platform engineer on Corda, and I spent about 7.5 years at Google as well, in Switzerland, where I worked on a bunch of things. I worked on Earth and Maps, and I worked on Gmail, anti-spam, anti-abuse, like bot detection technology, and also account security. So I led the team that created a sort of risk analysis for logins. So if people log in with the stolen password, it detects it and requests more information. And then finally, how I ended up working on Corda was I was an early adopter of not only Kotlin, but also Bitcoin. I was an early user of Bitcoin a few months after it was released. Back then, it was literally priceless. There was no price at all because there was no trading. So I had some chats with the mysterious Satoshi Nakamoto, who at the time didn't seem that mysterious. I thought he was just some Japanese dude who'd written some open source software. And then in 2010, I became a developer for 5 years, and then at the end of 2015, I was finished with that, and I got out and I said, I'm done with Bitcoin. And my biggest contribution there was actually writing this widely used Java library. It was written for Android, and it went on to be used in a lot of other projects as well. So it had over 80 contributors, and a few hundred developers wrote apps on it, and those apps went on to have about 2.5 million consumer wallets created. And that was a spare time project, which tells you a lot about the state of the Bitcoin ecosystem. And that was how I relearned Java, actually, because before that I was a C++ developer. Okay, so what does Corda actually do? I've said it's a sort of blah, 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 blockchain-inspired system for finance. What does it really do? The goal of this stuff, it's not completely hype or marketing-driven stuff. The goal of this software is to improve how businesses work together, right, by replacing message-oriented workflows, which is what they use today, with what they really want, which is a shared worldwide distributed database. And the history of the software business is one of successfully automating inside organizations and successfully introducing IT within an organization, but actually connecting organizations together. We're way less successful at that. We're really very bad at it. I was reading an article on the plane on the way over here, actually, about how American healthcare is largely driven by fax machines, and they still, when they move medical data between each other, they still use fax. And this is true even if they actually have IT systems within each organization. And in finance, this is especially bad. Finance is effectively just a giant paperwork crunching machine. The entire industry does nothing but move data around. And what they really want is actually, it would be great if there was like a big shared database they could all use. But of course, politically, they can't do that, right? Because if you were to do that with today's database technology, who would run it, right? You'd have a big Oracle instance, big Postgres or something, and the admins would be all powerful. You would have the financial system in one database. Very convenient for financial software developers, but politically completely unworkable, right? It'd be far too dangerous. So what you need is a new kind of database in which the nodes are distributed around the world, in which they don't trust each other, in which nobody really owns this shared database, and therefore which doesn't really have a conventional notion of administrators. And that is effectively what blockchain technology tries to do. And there's lots of applications for this. Big industries, anytime you find a big old industry that's relatively stable, so you're not going to find one company that just takes over everything like you see sometimes in tech, and in which there's lots of interactions between lots of organizations, this is the kind of place where it can be really useful. Right? So we have users and customers who are working in, obviously, finance, but also there's interest in healthcare, oil and gas, like rights management and tax paperwork and so on, cargo shipping. Consumer cash on smartphones is actually something quite a few governments are interested in, and supply chain integrity and probably more stuff as well. These are just the ones I know about. So, today is not actually a talk on what Corda is exactly and how it works and so on, how to build apps on it. That's a topic for another time. There are training courses available online and things, but if you're interested in sort of computer science, so you should look into it because there is some quite interesting stuff in there, even though it is enterprise software. So, for example, there's a peer-to-peer network, which is a little bit unusual for this space. It's inspired by the Bitcoin protocol, of course, because that's what I worked on, and I know it very well. There's lots of cryptography, as befits a system where no one trusts each other. In particular, Corda uses a new set of processor extensions that you can get in modern Intel chips. Everything from Skylake onwards has this set of features called SGX, and it allows you to set up encrypted memory space that can't be accessed by the operating system, or not only not by the operating system, but not even by like the BIOS and firmware and peripherals and so on, because the actual memory bus is encrypted itself. And we're using this to verify financial transactions in an encrypted, undebuggable space. So there's some interesting stuff there. We use coroutines. You've heard all about coroutines, 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 coroutines. We are using them in a slightly unusual way because we are using them to model business processes. So the act of coordinating a transaction, like I have some cash and you have some bonds or some stocks, for example, we would like to trade atomically. Setting up this business transaction is somewhat complex, and we use coroutines, not only coroutines, but actually which are serialized and checkpointed to a database to implement this. So you can kill your node in the peer-to-peer network, restart it, and everything comes back. Right? They're effectively like unkillable threads. We modify the JVM itself, or we modify a JVM, I should say, to make it fully deterministic. So this is where it's very important that everybody who checks a calculation that's happening on the ledger gets exactly the same result. You don't want, for example, someone to accidentally use a hash map and then iterate over its contents, for example, because that would be in random order. And if two different parties calculate different results for whether a transaction is valid or not, everything falls apart, everything explodes. So we're modifying an open source JVM to make it fully deterministic, which largely consists of deleting things from the standard library, but it also means things like modifying how hash code works and things like that. There's a lot of stuff around identity, not only to make everything legally, to allow legal identities to be verified, but also to allow an anonymity as well. Because it turns out that banking institutions and other financial institutions really love privacy and anonymity in the right contexts and at the right time, and their demands for privacy and anonymity are in fact more extreme than what you find in the cryptocurrency community, which is already, has a lot of people who are like doing drugs trading and so on, so they already like anonymity a lot, but the most advanced stuff in that space is really just table stakes for this space. And we provide, Corda is an application platform, right? To use it, you build applications in Java or Kotlin, or you could use other JVM languages too. And we provide a large sort of type-safe API for solving business coordination problems. Finally, if it's not clear what I'm talking about, you can go to corda.net, and it is in fact open source, right? Because if it wasn't open source, then we would be back to the system having administrators again. So being open source is a requirement of the customers, and we make money by making a sort of enterprise-enhanced version of it, where if you can still get the source code if you license it, perhaps, but the basic entry-level version of the software is open source. Okay, so that's enough about Corda itself, right? Let's talk a bit about Corda and Kotlin. So here are the vital stats. Here's why this is an interesting project for the Kotlin community. At the time I wrote this slide a few days ago, there were 117,700 lines of freshly written Kotlin. This isn't converted from Java or anything. This is written from scratch, so it's fully idiomatic Kotlin. There are actually around 28 developers at this point in London working on this project full-time. We've got a global training program in place, which has trained nearly 500 developers, and all of those people learn Kotlin on the training course as well. All these are from financial institutions. The enterprise repository has nearly 10,000 commits, although not all of those are ours, and it's 2 years old tomorrow. That will mark the day that I did the first ever check-in to the repository. So it's a pretty young project, but it's moving pretty fast. And around 95% of the code base is Kotlin. The other 5%, which isn't, is mostly sample code to prove to people that you don't have to use Kotlin to write code for our platform, right? Because being able to write apps in Java is a key selling point of our platform. And it's not enough for us to say you can do this and point at the Kotlin documentation. We actually have to show it too, so we have Java samples as well. This also, of course, helps ensure the Java API is as easy to use as a Kotlin API. So you may wonder, this whole story sounds rather improbable, of course. Why would a notoriously conservative industry like finance be funding a large project written in Kotlin? And I should say it is a large coalition of banks. I didn't mention this earlier, but R3 has over 100 members, over 40 investors, which are not venture capital firms, by the way. The startup it's raised investment from the customers themselves, so mostly banks. And it's getting wide-ranging support from across the industry, yet it is written in Kotlin. So, this sort of defies conventional wisdom a little bit. So why did we do this? Well, so like I said, I was an early adopter, so I already knew about Kotlin before this project started, and I knew I liked it, and I knew it would be good, and it would be very productive. And in fact, I knew this, and I was so sure of this, that when I joined R3 and I started writing the first code for Corda, we were using Kotlin before version 1.0 even shipped. Which is a double helping of unconventional. You wouldn't normally do this. I was willing to do this because I knew that 1.0 was around the corner, right? I've been reading the blog posts and been talking to Andre at the back here, for example, and he had said, we are going to ship 1.0, it's right around the corner, so that gave me the confidence to say, okay, we'll busk it for a few months, and by the time anyone notices, it'll be fine. Which is very risky. But everything in the blockchain space is ridiculous in some ways, so people actually kind of expect the unexpected. That's one of the interesting things about working in this space. Our competitors, if you look at what our competitors are using, we have two main competitors, IBM and JP Morgan. IBM's platform is written in Go, and they've sort of written a Java API, but it's not really finished. It's sort of Go is the native language of that platform, I guess. And then JP Morgan is a fork of Ethereum. And for those of you who haven't encountered Ethereum, this is a project which invented its own programming languages, its own compilers, its own virtual machine with its own bytecode set, even its own IDEs. So they basically tossed out all of the last 20 years of progress in the Java space and rewrote it all from scratch. And it will not surprise you to learn that there are a lot of bugs, and it's not very good. My favorite compiler bug in Solidity is if you write to one local variable, sometimes a different local variable will get corrupted, for example. This is supposedly a memory-safe language. Sometimes the optimizer replaces one number with a different number as it optimizes the program, which in finance isn't what you want, and so on. So, so yes, this was a calculated risk, right? We said, no, we're not going to build our own virtual machines or anything like that. We're going to use the JVM and modify it. And we'll build in Kotlin because we are starting after these other competitors, and we are therefore behind, right? And not only that, we are starting from scratch. We're not even forking or adapting a different platform. So this seemed pretty nonsensical to a lot of people. But I knew that using the Java platform would accelerate us a lot because there was so much infrastructure out there, and I knew that using Kotlin would also accelerate us. So this was a calculated risk, and it did work very well. Right, we've got no regrets. Would absolutely do this again. A-star, would absolutely buy once more. So people have come to accept this in the financial sector. They're actually pretty excited about Kotlin themselves. They got over it very quickly. which was very good. And the reasons it worked out so well, firstly, it makes our developers happier, of course. You all know why. But more importantly, it's allowed us to hire. We had to hire the entire team from scratch. I was the first developer, and I hired the entire team myself. And it's allowed us to attract better developers. It made them easier to hire. It made the act of building a competent team out of nothing in a very short space of time a lot easier, because people saw, they said, if we're willing to take risks like this in the name of developer happiness, then it must be a pretty good place to work. Right? So things that worked out really well. Everyone loves Kotlin. Well, actually, I say everyone. So we had one guy who was a contractor for a few months, and he hated it for some reason. He wanted to write everything in Common Lisp, and when we said that's not the language, when we said we don't use that language, he said, well, I'm going to write my code in Common Lisp, and you pay a contractor in India to rewrite it into Kotlin. So he said, no, that's not how this works. Other than that guy, everyone's been very happy with Kotlin. And this really rocks, right? I was expecting to be a bit of a loner. I was expecting to be having arguments with people about Kotlin, today, like still after 2 years of development. I was expecting this to be a really long, lonely, uphill slog. And it just hasn't been like that at all. So mainstream acceptance came really much faster than I expected. Obviously Google, but also Gradle, Spring. These are all names that are very well known in the financial sector, which sort of runs off Java. And this, cleared things out, and people don't complain. They don't ask questions about it anymore. They did a little bit at the start. They were like, really? Are you going to do this? But they sort of accept it now, and the big names getting behind it really helped. And this was nice. Some of the people who joined our team and who did very well during interviewing and have worked out very well for us, they considered us specifically because we use Kotlin, right? And they had competing offers, and they said, no, I'm going to go for R3 because I want to work with the best tools. We don't require, of course, people working in finance to use Kotlin. We have all the samples and all the training in Java as well, and we say that's what you can absolutely use. We don't even push it on people, really. But they often do use it. I would say about half of all people who build on our platform do adopt Kotlin. And that's pretty nice. They tend to like it, and it's a good way for them to get it into their organization, because blockchain is sort of a bit of a free pass to break the rules a little bit sometimes in finance, so it's a good way to get new tech into the thing. So I want to say, I think Dimitri's here, right? So, hello, yes. So you wouldn't believe how, these are small details, right? But you would not believe how much Docker really has helped with this, right? Because the nice thing about Kotlin is you can create something that looks like a Java API. It feels a bit like a Java API. And this is to such an extent that you can even generate Java docs that look like a Java API would. And we use this, and we really love this. This is the kind of detail that makes or breaks a project like this, right? Because it means that our developers who build on the platform can ignore the fact that we use Kotlin if they want to. And this is a big selling point for us, which no other platform, if you look at like Scala or whatever, they don't really get that right. And we use all the nice features that Kotlin has. We do use domain-specific languages. We use TornadoFX to do JavaFX user interfaces and things. So we pretty much fully exploit the language. Our style guide does not ban any features of it, for example. We pretty much exploit everything in there. OK, so let's talk about some unique challenges. The Corda API is a large API. It is an expansive API. It handles things like identity. It handles modeling of cache. It handles models of obligations and IOUs. It handles peer-to-peer networking. It handles cryptography. It handles hardware security and many other things as well. So, and we're a startup working not only under time pressure because it's a startup, but also because we have big, well-funded competitors like IBM, which is not the sort of company you normally want to be competing with. So, we've had to do this extremely large API very quickly. And so we relied very, very heavily on every aspect of Kotlin's Java interop, which is extremely good, right? We could not have considered Kotlin if it was not extremely good, but it is not quite perfect. So every so often we sort of we sort of catch ourselves on the edges of that. And I'm going to talk now a little bit about some of the areas where we found this to be difficult, because you all like Kotlin already, otherwise you wouldn't be here. So if I just sang its praises for 45 minutes, that would be pretty useless. We were, of course, very, very early adopters, and we hit the usual early adopter problems. Not as many as I thought we would, actually. It was fairly smooth sailing, but there were occasional rough seas. We don't use Kotlin continuations, by the way. We use a library called Quasar. Quasar works by rewriting bytecode on the fly. It does a static analysis of your code, and it actually rewrites code and then re-injects it into the JVM, which will then swap it in on the fly and recompile it and so on. So it's a pretty sophisticated infrastructure. Quasar is pretty good. It's not perfect itself. We have to use this, of course, because we need to support Java developers. So Kotlin's specific features we can use if it's optional, but we can't rely on or force people to use. And continuations are and coroutines, sorry, are a very fundamental part of our platform. Finally, of course, no one on the team knew Kotlin except me. So every single person who joined our team learned Kotlin on the job. Well, I say it's a challenge. It wasn't actually that big of a challenge. It took usually 2 or 3 days for people to get up to speed, and people were able to learn it pretty fast. We didn't even hire Java developers necessarily, by the way. Our team has a variety of backgrounds. Some of them were Java developers, some of them were .NET, some of them were C++, and so on. OK, so this is all pretty good. So what were the catches? Well, so I would say the first 18 months, and to some extent still, but it's got a lot better, was sort of a fight against IDE crashes. So the compiler has been very stable, but the IDE plugin, we hit a lot of weird edge cases and stuff, partly because the code base is quite large. So we reported lots and lots of IDE errors, and they've got fixed a lot, and it's much, much better than it once was. But say the first 18 months were the sort of teething problems you get in new languages. Yes, so there's still caveats for that. I'll go into some of those in a minute. So a big part of the value of Kotlin is IntelliJ, of course, right? It's not just about the language and the syntax. It's actually the amazing sort of refactoring IDE. And IntelliJ sort of tries to teach you how to use it a little bit. It's got tip of the day. That's about it, really. So what I noticed when I watched my team members is that most of them don't really know how to exploit this tool, right? And if they're not exploiting the tool, they're not getting all the benefit that I'd hoped to get out of using Kotlin. So we're going to do some stuff about this. I'm probably going to make some video tutorials with the tricks that I like to use and things. But yeah, better ways for people to learn all the neat things that IntelliJ could do would be really good. Corda uses generics quite a lot relative to most financial code bases. If you look at most enterprise Java, you'll find they don't really use generics that much. But I like them, and I wrote the code, so Corda uses them a lot. And this works out pretty well. Kotlin's generics are better than Java, but I would say people trip on issues with generics and type inference about once a week on average. That's our developers plus our community of app developers. And I'll go into what that means in a sec. Finally, so I mentioned already, we can't use Kotlin coroutines because we must support Java. We can't use Kotlin serialization for the same reason. We can't use Kotlin native for the same reason, and so on. So everything up to Kotlin 1.0 has been fantastic and awesomely useful for us, and everything after that, well, not everything after that, but most of the new big initiatives after that aren't that helpful for us because they're not really about integration with the Java ecosystem. So I'm not complaining because the things you get out of the box, even in 1.0, are pretty awesome. And we got it for free, right? So I can't possibly complain about this. Nonetheless, it is the case that as Kotlin moves away from the Java ecosystem, most of the new stuff is less useful for us. OK, so let's get a bit more specific about the stuff that we hit. Here are mistakes which crop up repeatedly in our code base, right? These are the ones which I really need tooling to help me fix. We forget these annotations. We forget this annotation as well. There's actually no reason why this stuff couldn't be on by default. The only reason these annotations exist, as far as I can tell, is because Android's Dalvik VM has a method count limit, right? Because all these annotations do is generate more methods. But if you forget them, the Java API that you get out of the compiler is worse, and quite significantly worse in some cases. So what we often find is that we write, our developer relations team writes a Java sample, and we discover the API is kind of sucky, and we have to go back and add these annotations, which is a bit annoying. Yeah, so Kotlin companion objects are sort of conceptually very nice. So they make more sense, I would say, than static methods do. Nonetheless, we don't want to use them because we're trying to make a Java API. But you can't get rid of them. They're always there, even if you mark everything as JVM static. And they show up in your Java docs. They show up in auto-completion. I would rather they just disappeared, to be honest, for us. We use the wrong thing in kdocs. This crops up all the time. So again, this doesn't make any difference until you generate Java docs and then you notice that you're missing it. So all this stuff, you'll notice the theme here, all this stuff is about making a Java-compatible API out of Kotlin code, which is sort of, I would say Kotlin is optimized for writing application code rather than platform code. So there's this and that. I think we've actually submitted a pull request to Docker to fix this one. I think someone on my team did that. Things like, again, Kotlin's notion of modules doesn't match quite the way the JVM works, so it's a bit confusing sometimes. People see these sort of mangled names in stack traces and so on, and there are these, people aren't always sure when to use these things and so on. So these are the kind of issues that trip us up. And here's some examples of the issues we sometimes have with generics. I don't know if you can see this because the colors are perhaps not that great for the projector, but at the top here we've got a type inference failure. So we've got a type alias agreements and liquidity pledge. That's the kind of type name that crops up all the time in this space. And the reason it's complaining is, so party is a subclass of abstract party, and it can't handle the variance there. So it turns out this was fixable just by using explicit typing instead of relying on type inference. But I collect these because every time one of my team hits one of these and asks a question, everyone chips in for a few minutes. It's, oh, why you tweak this, and how about that? And eventually we always fix it. But it does, I think this is the kind of thing, we've got a great error message here that would be worthy of a C++ compiler, and so on. So one of the things that this has really driven home to me is, why is Go popular, right? Why do people like the Go language, despite the fact that it is almost, it's basically Java 1.4 with a bit of type inference? Well, one reason is things like this. Static typing tends to mean generics, and generics are great up until you hit a brick wall with them and get an error that you don't understand, which happens a lot, right? Especially for developers who aren't really completely fluent in static typing, who may have a background in dynamic typing. They rely very, very heavily on Kotlin's type inference because that sort of makes it all magically go away, right? But then the moment you hit a limitation in the type inference engine, they get stuck. So that's the kind of thing where it's an interesting set of trade-offs, right? Sorry? Kotlin can emulate Scala quite well. So I don't know, I haven't used Scala that much, but this guy has Max, so I assume he's meaning that he's seen very similar type inference failures in Scala. Right, there's some capturing things. So this is what, often in these type systems you get non-denotable types and things like that. Okay, so here's the things that would really benefit me and my team when working with Kotlin. So these are the upgrade requests. This is really for, Dimitri and the JetBrains guys and Andre and so on. Public API mode. This has been discussed a few times. Public API mode would change the rules of the Kotlin language based on a command line flag or something. So for example, relying on type inference for the return types of methods, that's caught us once or twice when the inferred type wasn't what the developer expected. Things like demanding Java docs, requiring explicit visibility, possibly refusing to generate classes with a KT extension, which is a bit ugly for Java developers, and so on. There's a whole bunch of defaults you could change that would make it much easier to build Java APIs. And we would really benefit from this. We've had to sort of hack around and emulate some of this stuff ourselves. Java 8 bytecode support. Java has, because Java has evolved over time, they've had to evolve their API over time, and they've developed a lot of nice tools to help you do that, which would benefit us, because we're going to have to evolve our API over time too. But Kotlin, by and large, doesn't really use them. Another example of that is there are no raw types in Kotlin, which sort of makes sense from a design perspective, but it does mean if you introduce a class into your API and you would like to generify it later in a backwards compatible way, you can't do it. You could in Java, but you can't do it in Kotlin. Yes, so, it would be, in fact, what I would really prefer is in public API mode that these annotations are just always sort of implicitly present. It's just annoying noise and pain to have to manually specify these when building a Java API. Support for Jigsaw, same thing, better encapsulation and so on. Docker is so brilliant. Docker is 90% the most awesome documentation tool in the world, but we do hit bugs in it pretty frequently, and it's sort of quite obviously a bit of a side project. Yet, our API docs are one of the primary outputs of our projects, right? It's one of the primary ways developers experience Corda. So having someone full-time on Docker for a while just to push it over the edge would be really awesome. Yes, more robust type inference. I realize that type inference involves solving constraint systems and stuff like that, so it's not easy to make it more robust. But if it was more robust, then that would probably be one of the top productivity improvements for the team, because it means that people who are a little bit less experienced with advanced generics would be able to sort of busk it for a bit longer. Okay, so this is the last slide on Corda and Kotlin. These are the areas which I sort of see risk looming in future. Kotlin has come a long way by borrowing concepts that have been road tested in other languages. So, Kotlin is heavily inspired by, obviously, Java, but also Scala and C# and Groovy. But my sense is that the sort of library of concepts available for raiding is running low. So from now on, things will get more experimental. and we'll have to see like how that affects the language design and where the language goes. The Scala community sort of fractured a bit after lots of sort of Haskell developers came in and basically tried to turn Scala into Haskell. And will the same thing happen to the Kotlin community? It might do. It might not even be a bad thing if it does, right? I raise this as an area of risk, but I'm not actually convinced this is a risk. It may be that that's perfectly fine, and this sort of diversity in coding styles is not a problem at all. I'm still trying to figure out my own opinions on that. Kotlin and Java will clearly be diverging in future, right? Because Kotlin has now outpaced Java in quite a few ways. We see this in things like Kotlin modules not aligning with Jigsaw modules quite right. They don't have the same concept of visibility and things. Kotlin has its own coroutines implementation, and the Java guys are doing their own now. Java is getting data classes after Kotlin is. So in future, Kotlin benefits from this compatibility, but in future they may be becoming less and less compatible, which would be a shame. And then finally, I suppose this is the biggest risk that I see. So now we have Kotlin native and KotlinJS. There's going to be this huge temptation to like rewrite the entire world in Kotlin in like the common subset, and to expand the size of that common subset until you've ended up like reinventing Java. Basically, you've got like a new abstraction over the operating systems and platform and so on. So right now, it's very easy for my team to pick dependencies. They just pick the best Java library that's out there, and that's usually the best library, period. But in future, there's going to be this temptation to like, well, maybe I should use a Kotlin library instead of a Java library, even if the Kotlin one isn't quite as good. All right. So now let's talk about something completely different. That's enough about enterprise software, which I think we'll all agree is, even when working in the blockchain space, it is not the most exciting thing in the world. So this is a side project I've been working on. It's sort of an experiment. I don't know if I'll really take it through to full production usability and stuff, but partly why I'm introducing it here is to see if anyone wants to help me finish it off, right? So see if you're interested in this. So the goal here is to compile Kotlin and Java apps, right? So JVM apps to small native executables by embedding a little micro JVM to do the sort of thing that Go can do with generating little standalone command line tools, which are quite small. Right. And you can do this already. You've been able to do this for a while, but it was quite awkward and difficult to use. So Gumball is a program that makes it easy to use. And you may ask, why do we need this, given that we now have Kotlin native and other things? And I'll talk a bit about that towards the end. But the main reason is that this way you can use all of the Java libraries. Simple as that. So here's a demo. So this is what it looks like. You can see the sort of the jar of honey is, well, the jars, OK, so this is a simple application that just passes some command line flags, and you can see it's running not on hotspot, it's running on a separate JVM called Avian. I'll introduce Avian in a second. And this is what this application looks like. It's just like passing some command line flags, and yeah, it's at the bottom. I don't know if you can see this. So the binary is about 5.4 megabytes. So that's everything you need for command line passing and disk I/O and outputting to the console and so on. For comparison, Go would produce a program of about 2 megabytes for this size, so it's not quite as small as Go yet, but it could be with some more optimization. The unminified version, by the way, is 37 megabytes. The 5.3 second output time, that's without minification. So if you want a small binary, it takes quite a bit longer, which I didn't want to demo because that would just be a waste of time. So that's kind of what it looks like. Let's have a look at how it works. Hotspot is a very large and very powerful JVM. Which is often kind of overkill for many small command line tools. Avian is an open source JVM written by a company called ReadyTalk, and it's useful for embedded Java. It's written in C++, it's cross-platform, and it has it's pretty complete. It runs Java 8 code, it can handle invoke dynamic and lambdas and so on. It's got a JIT compiler that generates code. The code's sort of OK. It's a bit worse than maybe C1 generates in Hotspot. It's got a generational garbage collector. You can do ahead-of-time compilation. It even has an iOS backend and things. But the main reason that I use this is it has this neat trick where it actually can turn everything into a standalone statically linked native binary, including your jar and things. And it's got another neat trick, which is it implements quite a lot of Hotspot's internal API. So you can actually link it against the Hotspot code. You can link it against the OpenJDK code and use the entire regular Java class library, even though it's a different JVM underneath. And finally, it also has this final neat trick, which I haven't integrated into Gumball yet, but the SWT is a widget toolkit that abstracts the native widgets on each platform. So you can make native GUIs with this. It's a toolkit Eclipse uses. You can make native GUIs with this, again, in a native small binary. The Avian guys have a demo on their website of a program that demos every single widget, like progress bars, scroll bars, buttons, list views, and things. Every widget you've got in SWT, written in Java, linked with Avian, with all of the optimizations and compressions, and it's 1 megabyte in size. You can download it as no other dependencies. It statically links everything. Now, the thing that my program spits out isn't that efficient, right? They've used some neat tricks that I haven't used, but that's the kind of thing you can do. You can get impressively small programs out of this. So Gumball is a utility which automates the process of using Avian and turning it into a standalone binary. If you try and do this yourself by hand, you'll discover that you can do this and you can follow the instructions that come with Avian, but it involves like compiling OpenJDK, compiling Avian, using your custom linker. You have to write your own JNI bootstrap code and all this sort of stuff. So you've got to be fairly comfortable with C and C++. And what this tool does is it just eliminates all of that. So it does this, and it can actually Gumball itself, in which case the entire OpenJDK runtime is actually linked inside the binary, so you can download a single binary, and that's the tool. And I call them Gumballs because like everything is stuck together, right, into a single blob. That's where the name comes from. So let's compare this approach to other approaches. So limitations. The limitation is it's really just a side project. It was just me mucking about over a few weekends when it was raining, so it's not really that well finished. So for now, it's Mac only. There's no real reason for that. Avian runs on Linux and Windows too, and all I have to do to make it support that is compile the artifacts for Linux and Windows, and then set up cross-linking. So it's quite easy to do. There's no fundamental limitation. There are a few application compatibility issues to fix. Some apps don't like running on the boot class loader, for example. The main one, so that, the ProGuard is, we use ProGuard to do the dead code elimination. It's really slow. That's why I didn't demo in minification mode before. So writing a better dead code eliminator would be nice. There's an ahead of time compiler mode, so in that case the JIT compiler isn't used at all. But I experimented with that, and all it did really was make the binaries bigger. It didn't make them any faster, so that seemed like not a win. JVM bytecode is very compact, and you'd be surprised at the weird artifacts you get because of the memory hierarchy in modern machines. Native code is much, much larger than bytecode, so you use your cache less effectively in things in some cases. And then finally, yes, to do GUI apps, using SWT would be really nice. It's on GitHub. You can go grab it, and if you want to make it better, send me some pull requests. Finally, let's compare to other approaches. So versus Kotlin native. So Kotlin native, firstly, LLVM is a much more powerful compiler than Avian has. So you will get faster code. If you want to write video game, for example, I would not recommend using Gumball or Avian. LLVM will produce much better code. So Gumball is just Java, so you get all of the nice Java libraries that are out there. But what you don't get are things like C interop, you don't get nice pointers. The iOS app, which are demoed in the keynote, for example, you could make that with Gumball and Avian, because Avian does have an iOS backend. But would it be a smoother developer experience? No, probably not. It probably would not. Finally, there's a second alternative called Substrate VM. This is not very well known. This has come out of Oracle Labs and research by Johannes Kepler University in Linz. So if you download the Graal VM, which you can get on Oracle's website, this is a new JVM, effectively. Substrate VM is actually written in Java itself. The entire JVM is itself written in Java. And it has this tool called native image, which spits out, you give it a Java application, and it actually not only statically links it all with a full-blown JVM, but it does a much more advanced compiler optimizations and things. And it spits out binaries of around the same size of Gumball, so little command line flags tool will generate about 4 or 5 megabyte binary. But you'll get much better compiler optimizations and things, and it does it a lot faster. It's a better tool in general, but it is not open source. So those are the alternatives, I think. There are a few other tools that do this, but those are the ones I've compared against. And like I said, if you would like to help out, let me know, and it might be a nice competitive advantage versus Go. That's my talk. Thank you very much for listening. And if you have any questions, let me know. I think we have maybe 5 minutes for questions. Is that true? Yes?
How do you use this native cryptography on a CPU?
Oh, SGX? That's a very large topic. Yeah, we might want to talk about that afterwards if you're interested in SGX. So there's an SDK. You need compatible hardware. There's an Intel SDK. What we've done actually in Corda is we've embedded the AV and JVM into the enclave, so you can write code that runs inside this encrypted memory space in Java. If you don't have that, by the way, it's like embedded programming. There's no operating system access inside the enclave. So you take everything with you. You provide your own C library. You can't access the hardware at all. You can only do computation under memory, and everything else you have to like call out to the OS and pass encrypted data in and out. It's a bit of a pain, the programming model. We might in future provide like a Java-type abstraction over it to make it easier to use.
So would you say that Corda is not compatible with Java 9? Oh, I'm sorry. Would you say that Corda is not compatible with Java 9 right now?
I think we tried it and it didn't start up. Java 9 is not really compatible with very much itself right now, but I think it'll be easy fix. I have looked at this in the past, and we intend to upgrade fairly soon, partly because Quasar gets better if you run on Java 9. It's easier to do these coroutines on Quasar.
Mike, what would be the recommended path to start, working on Corda, or, to create Corda apps and, try to build a platform on that?
Yeah, okay. If you go to corda.net, there's tutorials. There are video tutorials, there's textual tutorials that will take you through writing your first application. There's also a lot of sample apps, so you can see how to build applications of varying complexity. We're also going to release, we took part in a competition with the Central Bank of Singapore to create what is effectively a new peer-to-peer real-time gross settlement system. So the system that moves money between banks, right? And I think that code is being open sourced as well. Yeah.
So I presume you're solving the problem Equifax is demonstrating, identity and reputation.
Yes, well, Equifax demonstrates many interesting problems, doesn't it? Yeah, so nodes in the network have a sort of cryptographic identity, and it's a bit stronger than what's your social security number, yeah. The other, so I mentioned we use tornado effects, actually. We ban web technologies inside the Corda core because it's not secure enough. And we use managed desktop apps as an alternative because they're sort of structurally more secure than web apps. Yeah.
So we're probably the closest thing to like the Haskell people again that came to Scala. Okay. Nobody wants the Scala thing to happen again. Like I think a lot of people learn from those mistakes. Have you found a correlation between inheritance and the problems with type inference in general?
I haven't really studied the type inference failures we've seen, but I guess the example on the slide involved inheritance, yeah.
Yeah, okay. Cheers.
While subtyping, yeah. Are there any more questions? Oh, there's one more. And then we'll call it a day.
Sure. What were the 3 most important reasons you chose to use Kotlin instead of Java?
Creates a Java-compatible API out of the box. JVM is the best platform for doing this sort of business, high-level business-type logic. And I just enjoyed using it, and I knew it was a well-run project, and I trusted the team. That's actually like 5 reasons, isn't it? I cheated it. Okay, let's go get a drink then. Thank you.